Hello everyone and welcome to today's webinar on the operational SPaT challenge deployments, the 7th webinar in the SPaT challenge webinar series. My name is Nilu Parvinashtiani and I will help facilitate today's webinar. So today's webinar is hosted by the National Operations Center of Excellence, or NOCO, and if you don't know already, I wanted to share with you that NOCO is a center for sharing resources on the transportation systems management and operations, or TSMO. So a few ways for you to connect with us is, first of all, you can use our NOCO Knowledge Center, and you can find the link on the useful links box on the bottom left side of your screen. We have hundreds of different TSMO resources in the Knowledge Center, as well as like previous webinar recording that can be found on our YouTube channel. Also, if you want to keep up with different TSMO news and like centers, different announcements, make sure to subscribe to our bi-weekly NOCO newsletter or our Twitter account. And one last link that's going to be very useful and will probably be mentioned later is the SPaT Challenge Resources link. So you can find different documents and also like previous webinar recordings over there. Let me cover a few logistics before we start off the webinar. This webinar will be recorded, and that recording along with the presentation slides of today's webinar will be shared with you through a follow-up email after the webinar, and also through the on-demand learning section of the NOCO website. We intend to have an extended question and answer session at the end of the webinar. So if you have any questions during the presentations or at any time, we encourage you to put it in the question discussion pod here. So we already received some of your questions through the registration link. So we will be asking those questions at the end from our panelists here. So let me quickly go over today's agenda. I have asked the speakers to briefly introduce themselves, but also you will have access to their full bios on our website on the webinar page. So today we will have first Blaine Leonard from UDOT DOT, who will go over an introduction of this webinar series and the SPaT challenge. The SPaT challenge resources that we have. That will be followed with 3 short presentations before the extended Q&A. So first off, we have Joanna Wadsworth from the city of Las Vegas, who will share her experience with deployment of the SPaT challenge, and then that will be followed by Liz White from VTTI, who will cover Virginia's experience with the deployment, and finally we will have Blaine again, who will talk about Utah DOT experience. And as I mentioned, that will be followed with the Q&A session. We'll have all the panelists there to help answer your questions. And that's all I had to cover, and with that, I'll hand it over to Blaine to start us off with the webinar.
Thank you, Nilo. Happy to be on the call today with everybody, and I appreciate everybody joining. We've got about 50 of you on the call today, and hopefully we can provide some information that's useful and answer some of your questions. If you're on the call, I'm assuming you're pretty familiar with the SPaT challenge. The SPaT challenge is now a little over 2 years old, and in essence, we're challenging infrastructure owners and operators around the country to deploy DSRC infrastructure and broadcast SPaT and map messages in at least one corridor in each state by January of 2020. We've made a lot of progress in these 2 years. We've got about 35 locations in 25 states. We've got a couple others that we're trying to get on the map, and we'll expand that a little bit as we continue to talk to folks. This represents about 500 roadside units that are currently operating and about 2,300 more that are planned for operation over the next 18 months to 2 years. And we encourage all of you to continue working towards this goal and to fill the map. As you may know, we've conducted 6 webinars to date. Today's the 7th one. And as Nilo mentioned, if you log on to the SPaT Challenge site on the National Operations Center of Excellence, each of those webinars are recorded and are available for you to listen to if you missed them, or listen to again if there's something you're trying to figure out or remember from one of those webinars. And they're recorded by individual presentations, so you can listen to one piece rather than another. Our first webinar was in early March. It seems like a long time ago now, where we introduced the SPaT Challenge and talked about systems engineering and concept of operations, and a little bit about selecting a corridor and looking at costs and procurement. The second webinar was just shortly after that, where we talked about SPaT messages and the V2I hub and some agency experience with deploying onboard units, even though that's not directly part of the challenge. And then we had a focus in April that was really about map messages and how to create those, and a little bit about vehicle GPS correction. We had a specific demonstration in April of the USDOT Map Creator tool, and really focused on that on April 24th. And then we had a session in May talking about the RSU specification and roadside equipment and DSRC licensing. Our most recent webinar was in June, early June, about a month ago. We talked about security credential management, verifying the deployments, making sure that the messages we're sending can be heard, and then talked a little bit about some of the support services that the USDOT is offering for those of us who are working in this arena. So I would encourage you to go to the SPaT Challenge website, look at some of these resources, download the SPaT Challenge verification document if you haven't done that, and take a look at that, and to register for our next one, which is next month. We would really like to know from those of you who are planning to deploy about your deployments. If you've got a pin on the map already, we'd love to have you update that if you've got any progress about timing or scope. And if you're not on the map and you're working towards a deployment, we would certainly like to have you on the map, and here's the location of how you can do that. You can click on there and give us a little bit of basic information about what you're planning to do. We'd love to put you on the map so everybody knows what you're working on. Here's the resource page, and it shows some of the documents we've produced and a few others that we're still trying to work on to get up there to help everybody in whatever way we can as we all deploy together. I mentioned that we've got another webinar planned for next month, and it will be a little bit about beyond the SPaT Challenge, looking at some sites that are doing more than just SPaT broadcast, and talk a little bit about what we're starting to call the Connected Fleet Challenge, where we are planning to encourage all of us and other agencies to start outfitting some vehicles as well. So there's a lot more information out here that we're trying to work on, and we hope to have you join us on that next call as well. So with that introduction, I want to thank everybody for being here again. I want to turn the time over to Jonah Wadsworth to talk about their deployment in Las Vegas. Jonah.
Thank you so much, and good morning, everyone. To those that are, I guess, on the West Coast here, good afternoon to those on the East Coast. My name is Joanna Wadsworth, and I'm a program manager with the City of Las Vegas. I've been involved with the city's advanced mobility projects, including our connected and autonomous vehicle deployments. I'd also like to take the opportunity to thank the National Operations Center of Excellence for providing this opportunity for me to participate in today's webinar and to share our operational deployments that are currently underway within our city. So as a traffic engineer, I have to say it's just a very exciting time that technology is developing at a rapid pace, and it's providing us new tools to solve the challenges that our communities face. So for the City of Las Vegas, as far as why did we jump into our DSRC deployments and our smart city deployments, Like many communities, we have challenges that we're facing that include our rapid population growth that is putting strain on our roadways, and we continue to experience traffic-related injuries and fatalities. And so our goal is to provide a safe, convenient transportation network that has modal choices. Our planning really started back in 2015. Our city undertook a comprehensive planning effort to develop a citywide 20-year vision for transportation, which is known as our Multimodal Mobility Master Plan. And in parallel, the city also prepared an application for the USDOT Smart City Challenge. It was during these planning efforts that a roadmap was developed for the deployment of the emerging transportation technologies. And so this presentation will provide you a top-level overview of the deployments that we have underway that include the DSRC deployments. So for those that are not familiar with the Las Vegas Valley, I just want to take an opportunity to give you an overview of the locations within the valley here. Most people are familiar with the resort corridor there. Just flashing is a gray highlighted area. That's our resort corridor where a lot of the larger strip casino hotel properties are located. And in the flashing purple area that's overlaying the yellow area is the City of Las Vegas official boundary. So that's the City of Las Vegas jurisdiction. So we're generally central to the valley, over to the west and into the northwest. And one of our regional partners is the Regional Transportation Commission of Southern Nevada. And one of their divisions is the Freeway and Arterial System of Transportation, and they have a transportation management center which provides regional transportation management. They're definitely a project partner of ours as we deploy our DSRC and technology projects. I'd like to note that we have a traffic signal shop in the northwest of the valley, and this is an area that has helped us to program and troubleshoot some of our DSRC deployments, and I'll provide a little bit more information about this facility a little bit later in the presentation. But then the item to note here is the area highlighted in yellow. So this is our official boundaries for downtown Las Vegas, and the City Council in 2016 designated our downtown as an innovation district. And so we're focusing our initial smart city and technology projects within this area. And this is the area of our current DSRC deployments, and we'll focus on this area today. So our first jump into the DSRC deployments was within our innovation district, and it was in support of our driverless shuttle project that was in the Fremont East Entertainment District. The project is a public-private partnership between the city, Regional Transportation Commission of Southern Nevada, AAA, and Keolis. The project is a one-year deployment of the Navia Arma driverless shuttle, and it's free and open to the public to experience. And so on this overview map, the light blue dots there indicate where the DSRC were deployed. The DSRC are consignia, our regional controllers are trafficware, and the DSRC are broadcasting SPaT, the SPaT and map messages. So this slide here, with this first implementation of the DSRC, integration was required with them, as well as the learning curve of how do you program them, how do you integrate them with our traffic signal controllers. And so with our Traffic Engineering Field Operations Center, we have a functioning traffic signal shop, which many cities probably have. But our team installs a DSRC on the exterior of the building and did a hardwired connection to a functioning operational traffic signal controller in a cabinet within the building. This setup provided us the opportunity to control in a controlled environment, to program, test, and integrate the units. And it also allowed us to verify that the units were integrated and functioning before they were installed on the roadways. The other feature that I'll just point out is that adjacent to the building, we do have a 2.5 acre paved area that is used for vehicle heavy equipment operator training, but we also doubled this area into a test area for our driverless shuttle. So we were able to test the communications with the vehicle before we went on street again, and that's the photo on the left-hand side there. So, you know, as far as a lesson learned or recommendation for other communities, it was great to have this set up at an off-site facility to provide the ability for us to test the roadside units, other smart city IoT sensors, and connected vehicles, and provides an learning opportunity for our in-house staff. So just a little bit more detail on our driverless shuttle project. It operates on a clockwise loop that is connected to 6 traffic signals and 2 stop-controlled intersections. Our city field operations team installed the DSRC. The vendors, Comsignia, and a local firm here, Southwest Traffic, provided the programming and setup of the DSRC units. If you're in downtown Las Vegas, you can experience the driverless shuttle. It operates Tuesday through Sunday, 4:30 to 9 p.m. There are times when special events or weather impacts the operating hours, and so AAA has created a website noted on the bottom of the slide, AAA.com/hop-on, where you can get up-to-date operating hours. But this project provided the team and partners firsthand experience with the driverless technology. It also provides the opportunity for the public to ride the shuttle. For many, it's the first time they're exposed to the driverless technology. And since the shuttle was launched last year in November, it has now carried over 28,000 people and people of all ages. Riders are asked to rate their experience, and they have rated it 4.9 stars out of 5. And so there's been very positive feedback, and riders are excited to see driverless technology as a mobility option. You know, one item to note with this driverless technology in the driverless shuttle is that it depends on the DSRC for communication with the traffic signals. It does not have vision to detect whether the traffic signal is red or green. And so working with Comsignia, they provided the city and Keolis a diagnostic tool, an onboard unit that is installed in one of their pilot vehicles. And so this vehicle is able to drive the corridor prior to operations each day, just to make sure that the DSRC are operating, and that if there's any issues, they're able to alert us, and we can respond. So our second operational deployment is identified with the green dots on the map. These DSRC are installed on Casino Center Boulevard from Bonneville to Fremont Street. For this deployment, the DSRC are manufactured by Siemens, but the controllers are traffic-aware. And this slide provides a little bit more detail on that deployment. Casino Center, for those that have visited downtown, is a main north-south corridor, and it provides connection to downtown destinations, but to the north it has a connection to the freeway, so there's a lot of travel. And it's one of our primary bus routes. It has one general purpose lane in each direction, but exclusive center running bus lanes, so it makes it a very unique corridor in which the V2X technology, we believe, will enhance the safety along this corridor. The legend on the right-hand side highlights the applications in which we're developing for this corridor, and I'll highlight just a few. As I mentioned, the corridor has a center running bus lane, and personal vehicles, drivers routinely enter the exclusive bus lane, and this is a safety concern and has the potential to impact operations. And so this application will feature, basic safety messages to those drivers to, that they're entering a bus-only lane, and it can be expanded to alert the bus driver if there's other vehicles that are not supposed to be in that lane. On the southern end of the corridor here, too, there are 2 one-way streets. Bonneville is our eastbound one-way street, and Clark is our westbound one-way street. And we see a fairly high number of wrong-way entries that have resulted in collisions, both pedestrian and vehicular. And so we're looking at, map messages or basic safety messages to alert folks that there are one-way streets to not enter, and also pedestrian alerts. So this project began in January of 2018. The installations are complete, but the programming and integration is still underway with the Siemens team. And it's anticipated that within the next month we should have some of the applications deployed. I'll also note that we did installs on 6 city fleet vehicles so that we can see the messages, help with the integration, and again, ramp up on the connected vehicle technologies. Our third deployment here in the downtown area is highlighted with the purple dots on the map. These dots represent CODA wireless units that were installed with a connected corridor project that we have underway with Cisco. And the city field operations team installed those units, and Cisco is in partnership working on the integration of those units. While the integration is still in process, the units are able to communicate or listen for connected vehicles that are on the road. So the information that is being received by these CODA wireless units is being consolidated into a dashboard. And while it's still in development, it is still providing us some pretty good information about connected cars that are on the road. During CES, we had this dashboard active and listening, and there were quite a, as you can imagine, during that time period, there were quite a few connected cars on the road, so it was kind of neat to see. This screenshot was just taken last week, and I believe it picked up one of our city vehicles that has an onboard unit on it. But it's able to see connected cars that are in proximity of the CODA units in real time. The purple dots indicate the location of those vehicles, and it collects their location information, their route, speed, if they had any basic safety messages that were being broadcasted. For example, we recently had a rain event, which is an event for us here in Las Vegas, and a number of vehicles were broadcasting traction control alerts. And so on the right-hand side on the corridor where you see a number of red dots or red alerts in line there, those were traction control alerts that were being broadcast by a number of vehicles. So the city intends to integrate all of the DSRC, or at least those in areas to pick up the entire downtown area into the system and use it for real-time performance monitoring and incident response. And the historical data is also of interest too for planning purposes, to see historical trends and insights into how the roadways are operating. And for example, if there wasn't a rain event and there were traction control alerts based on water, do we have a drainage issue on the roadway? So there's a lot of things we can learn from information coming from the cars. So the next slide here, the dots, is a project that we're currently working on. We anticipate the installations to go up in early August, but it's noted in the darker blue dots on the map. Those installations will be Consignia DSRC, and we're looking to install those on Las Vegas Boulevard from Sahara, which is a southern limit that extends beyond this map, but it'll go north to Stewart with a loop on Ogden and Stewart. These installations will be an extension of a project that was completed in partnership between Clark County and Aptiv. They had installed DSRC units on Las Vegas Boulevard in late 2017, south of Sahara to the Welcome to Las Vegas sign. I believe there was 43 roadside units installed in that project. But I'm not sure if you heard, but Aptiv, in partnership with Lyft, provided driver-free rides during CES utilizing the Las Vegas Boulevard deployments. That CES pilot was a success, and now Aptiv and Lyft are continuing their partnership to offer the driver-free rides. So the city's installation of these DSRC north of Sahara will provide an expansion of that route, and it will also expand the city's DSRC deployments within downtown per the overall communication master plan of the Innovation District. And that's what this next slide shows. This final slide illustrates the planned future deployments of DSRC within our downtown Innovation District, and we're looking at the deployment supporting our vehicle, pedestrian, and bicycle safety applications. As far as lessons learned go, over the last year, the city team has gained experience and knowledge during the DSRC operational deployments, as well as working with our RTC FAST partners. It's just really important to have open communication with all project representatives, from your public sector to your vendors that you're working with. There most likely will be integration needed, and so coordination is very important throughout the project development. Another item to note is to account for the installations in your project schedules. In our first deployments in support of the driverless shuttle project, I thought the driverless shuttle was the critical path item and setting up the roadway for that. But as the project developed, the DSRC was the critical path item. And with any new piece of equipment, there's a learning curve and process to integrate it into an existing system, so it's recommended to just account for that in your time. And not listed on this slide, but just something important is that don't be afraid of small pilots or demonstrations. The projects that we've worked on really allowed our city team to have hands-on experience and learning opportunities. As far as next steps go, we'd like to continue to build our current operational deployments and continue to build on our smart city environment. We are definitely looking at the central management system for programming and monitoring of all of our DSRC, regardless of the make and model of them. Right now we're using the individualized management software for each. The other is redundancy. So as the number of driverless vehicles increase on our roads, we want to make sure that there's no downtime if a DSRC malfunctions. So looking at how DSRC can overlap within our system and broadcast for another intersection in case another one, the adjacent one goes down. We want to continue training of our in-house staff for programming and troubleshooting of the DSRC. And finally, we're integration of the connected vehicle dashboard into our planning process and our response services. Provide logins for our city team so they can make use of the data. And just you can keep up to date on City of Las Vegas projects. We have a website for our innovation district. It's innovate.vegas, and we provide current news and updates on that website so you can keep up to date with us. And with that, I'll turn it over to Liz White with the Virginia Tech Transportation Institute. Thank you.
Thank you, Joanna. So as she said, my name is Liz White. I'm a research associate at VTTI with the Center for Technology Implementation, and I've been helping to manage our VCC deployment for the last year or so. And I just wanted to mention a few of their team members that will likely be joining me for the Q&A session. John Paul Toledo Valela is an embedded hardware team leader here in our Center for Technology Development. And Mike Mollenauer actually created this slide deck, but he won't be able to join us today, but he's the director of our Center for Technology Implementation. And Zach Dorzoff may be joining us as well at the end, and he's the director of our Center for Advanced Automotive Research here at VTTI. So this first slide just shows where our Virginia Connected Corridor testbed is located. So our primary deployment is in the Northern Virginia area, and we also have a smaller deployment in Southwest Virginia on the Smart Road here at VTTI, which is a closed testbed research facility that we manage and is owned and maintained by the Virginia Department of Transportation. And VTTI has partnered with VDOT on this deployment, and our mission, as you can see here, is to provide an open, connected vehicle environment where technologies and concepts can be developed, tested, deployed, and evaluated in a real-world operating environment. This next slide shows a little bit more detail of the Northern Virginia testbed, which is our primary deployment. And this testbed is located along several of the most congested corridors here in the United States, which is why we chose to deploy on these particular roads. The lighter colored pins here show where we have DSRC RSUs with SPaT and MAP capabilities on them. We currently have 30 of those equipped intersections in total, and we also have 19 RSUs located along major freeways, which are I-66 and I-495, that do not currently have the SPaT or MAP capabilities. And we specifically chose to deploy SPaT and MAP on this set of contiguous intersections so that people driving through the area could receive information from each intersection, and also so we can send data from those intersections to associated applications. This next slide here is a representation of our VCC cloud system, which is a data hub and archive, and also does application processing. As you can see in the upper right-hand corner, we do make all of our data from the VCC publicly available through a website called smarterroads.org, and data is pushed there on a regular basis. We're also tied into some of VDOT systems such as VA traffic and exchange data with their systems. The VCC Cloud also exchanges data with two applications that VTTI has created called VCC Mobile and VCC Monitor. Those are shown in the brown boxes on the left here. VCC Monitor is a web-based situational tool that we use for monitoring activities and events within the VCC environment. And we use that tool to monitor all of the equipment in the field in real time. VCC Mobile is an Android-based mobile application that provides an engineering-level user interface platform that can be used to test application exchanges with actual drivers. And we also have a few work zone applications that we're currently working on that send relevant work zone information to passing motorists. So next I'll talk about our SPaT development parameters. Our mission here in deploying SPaT was to deploy in a working VDOT system, which meant that we had to deal with existing VDOT equipment and capabilities. So we didn't go out and procure brand new equipment that had all the nice capabilities already built in. We had to work with what VDOT already had deployed. So therefore we were constrained to using the McCain 2070 controller, which is running the Advanced Traffic Solutions or ATS D4 firmware. That firmware, when we first started the project, did not have the capability of directly producing SPaT data or the underlying data that could be used to produce SPaT, so we had to develop a custom interface for that. So we contracted ATS to essentially build this interface that will push data through one-way communications protocol that pushes the data through a firewall to satisfy safety concerns. So just to clarify, we're only going one way with the information right now. So data is coming out of the controller, so we can then use it on the RSU and the cloud after that. We're currently running version 4 of the RSU software. From a SPaT perspective, the RSU is set up to listen to the firewall port for any incoming data. And when we do get the data, we receive it and then convert it into the J2735 version 2016 SPaT message standard. So basically, VDOT they're sending us the raw timing and phase data, and then we decide how to build it, encode it, and broadcast it once we receive it. We're not just broadcasting from the local intersections, we're also pushing the data back into the VCC cloud where we archive it and then also make it available for our cellular application users and any additional applications that may be available in the future that we may want to pick up on aggregate SPaT data. From a security perspective, we aren't running any SCMS right now. We don't have any available providers. I've not necessarily had the requirement to go out and do that at this point. All right, so regarding map file development, we initially built our own tools to develop the map files using photogrammetry, which is essentially top-down photos, and then we click out points to define the lanes, and then use our own code that we wrote to process and put the logic in to determine the approaches. And we did that for the first 6 intersections, and quickly realized that that was going to be a very time-consuming process and difficult to maintain. So at that point, we found out that there was the UDOT map tool that had been developed, that we could use that to follow the same kind of process that we had been using, but it was much faster and then would follow along with the UDOT implementation standard. So once we have the map file developed in terms of where the lanes and approaches are, we take an output of the tool that VDOT uses called MIST, and that's VDOT Central Signal Management System that they use to update and control all their timing plans on the 1,400 intersections that they have in the northern region operation. And we're able to get that timing plan information out of the MIST system and manually assign phases and complete the map files that way. Currently, our map files are relatively static. We build one up and push it to the RSU remotely using VCC Cloud. and we aren't necessarily able to automatically reconfigure or support changes to the intersection or even daily changes to the flow of traffic, for instance, but we do intend to develop tools to do that sometime in the future. This next slide just kind of shows the flow of data throughout our system, and there's really two ways that we can get data to an end user. It all starts with the McCain 2070 controller, where you can enter a port and IP address to enable the flow of the raw signal and timing data through the firewall. The RSU is then set up to listen to that port number at the firewall and take in that data. We then process, encode, and broadcast it. So that's really the most direct route to get data from the intersection. We broadcast it out to a motorist that has an OBU passing by. Additionally, we're able to forward that same message into the cloud, where we can use it in our VCC monitor tool, where we can zoom in on intersections to see a live display of the SPaT data to validate and verify that it's coming through appropriately. We can also make it available to people that have our VCC mobile application, so they can pick it up and get the SPaT display on their phone interface as well. So next, as far as vehicles that we have out there able to receive this information, we currently have a variety of vehicles deployed on the VCC that are capable of receiving SPaT and map data. We have a fleet of 50 personally owned production vehicles that have level 2 automation capabilities that we've instrumented with technology to be able to monitor their performance. And we tested out their use of the VCC mobile application over a period of 12 months of data collection. And beyond that, we've invited various groups of users to also use and try out the VCC mobile application, and the number of people using that varies from time to time. And currently, we're also seeking out third-party application developers who may be interested in developing and testing applications on the VCC as well. So as far as SPaT and map validation, there are a few things we're doing on that front. First, we're evaluating the accuracy and latency of SPaT and map messages. And to do that, we've added a custom wrapper code so that when messages are received and then rebroadcast or transferred throughout the system, we essentially get a list of routing and the timing of where that occurs, so we can see each message and each hub, the routes it took and the time it took to get from point A to point B. We did a fair amount of data collection on the roads and logged the data on our VCC mobile app, and that's currently being used to develop a profile for latency and the characteristics of how the data flow through the system. And those paths that we're really interested in are coming from the controller and into the RSU, and then also into an OBE if it's an integrated system on a vehicle, or the controller to the RSU to VCC Cloud, and then to the VCC mobile smartphone app. And we're just trying to understand how those two paths may vary in terms of latency and what impact that could potentially have on applications that we intend to deliver in the future. We've also looked at the SPaT challenge verification document from CAMP to understand their expectations regarding how the messages should be implemented. We went through and evaluated those requirements and have updated several parts of our system, most having to do with how this data can be interpreted. There are still a few missing pieces that we're working on. One is an RTK system that we're using to provide a source for RTCM corrections that will be broadcast out from the RSU. And one of the more time-consuming pieces is also to modify our map messages to support longer approach lengths as prescribed in the document. Currently ours are relatively brief, and we understand the need for the longer approaches. It just takes a little bit longer to put that together. We've also recently added pedestrian phases to support third-party application development, which is addressed in the CAMP document as well. And we've also developed some post-installation and field maintenance validation tools. So we've actually developed a piece of equipment that VDOT's roadside maintenance contractors can use to verify that the SPaT and map messages are being transmitted properly after they perform maintenance on a signal controller. So that's a nice way for them to be able to validate that the system's still working as expected after they complete maintenance. As far as future plans, we're really looking forward to developing our own SPaT and map-enabled applications. We have interest in various applications, some of which are listed here, such as red light violation warning and eco approach and departure. All of these applications are things that we're planning on working on with VDOT in the future, And we also have some traction with OEMs who are interested in coming in and testing their applications in the VCC environment as well. We're also likely to expand the VCC environment, add more RSUs if and when the use cases deem that necessary. Like I said, we currently have 30 out there on 3 or 4 major corridors already implemented, so that's a pretty good test bed for us currently to be able to learn what we need to learn before this becomes more mainstream. And as far as lessons learned, I'll just touch on these briefly since this may come up in the Q&A session as well. I think as Joanna touched upon too, it's important to have regular coordination with the different agencies involved in the deployment. So that's really been helpful. We've found that working with actuated signals has a pretty big impact and is more difficult than just using fixed timing signals. So that's something we've dealt with. And again, the map files tend to take a significant time and effort to develop and validate those. And that is the end of my presentation here, and now I will turn it over to Blaine.
Thank you, Liz. Appreciate that. I enjoyed the presentations from both Liz and Joanna today and learned a lot. I think they were really helpful and gave us some good information. I've had the opportunity to get down to Las Vegas and ride Joanna's Navia shuttle on Fremont Street. I would encourage anybody who has a chance to get over to Vegas to take an hour and do that. I've also had the opportunity to visit Liz's Virginia deployment sites and look at some of that. So that's very interesting, and it's good to see a little detail about that. I'm the Technology and Innovation Engineer here at UDOT and the person in charge of our Connected and Automated Vehicles program. So I just wanted to walk you through our deployment here in Salt Lake City and tell you a little bit about what we've done and how we've done it and give you some ideas about that and maybe address some of the questions. We started deployment here about 4 years ago, and our intent was to build a corridor with DSRC on it that we could use for deployment and testing and get ourselves prepared for equipped vehicles which are coming at us in the next few years. But we also, as we planned for the deployment, wanted at the end of the day to say we've got an application that could potentially give us some benefit. And so we brainstormed and looked around and tried to figure out what kind of applications we might be able to do on a limited scale, something we could do small and scale up later, and realized we needed vehicles to make something happen. So we partnered with the Utah Transit Authority and basically built a system that allows transit buses, when they're behind schedule, to ask for priority at the intersections. And the goal there was to increase schedule reliability. On this particular route, the transit agency told us that their buses experienced a challenge in many cases because of the traffic and were often only 86% reliable on schedule. System-wide, their system is closer to 93 or 94%. So that established a goal for us to improve transit schedule reliability while minimizing the impact to the rest of traffic. While we were starting on the deployment, the SPaT challenge came around, and so of course this becomes our corridor for the SPaT challenge as well. This is an 11-mile UDOT-owned arterial on the west side of Salt Lake City. The corridor is actually longer than 11 miles, but we took an 11-mile piece of it because it coincides with Route 217 of the Utah Transit Authority bus system. This corridor has 30 signalized intersections. We've got full fiber optic connectivity along the corridor. All the signals are connected to our central traffic control system, which is Intelight MaxView. And we run ATSPMs, the signal performance metrics, on all of these signalized intersections, so we get a lot of data out of the controller. We have 2 different brands of signal controller on the corridor. 4 of them are Econolite Cobalts, and the remainder of them are Intelights. You see my numbers don't add up. I just noticed my numbers didn't add up. Sorry about that. There are 30 signalized intersections there. We then went ahead and started installing DSRC RSUs on these intersections. We eliminated 6 intersections because they have some other kind of complexity going on, and we actually didn't want to mess with them. So we've got DSRC on 24 intersections. We made a conscious decision up front to try 4 different brands of DSRC to play with the interoperability issues and to look at performance and those other kinds of things. And all of these intersections are now actively broadcasting SPaT and MAP. Here's some photographs of the installation. This you can see that in most cases we've installed our RSUs either on the signal pole, on a luminaire above the pole, or out on the mast arm a little ways on a little post. Unlike many other cities, we don't have a lot of, particularly on this corridor, we don't have a lot of tall buildings to get in the way. These are omnidirectional antennas, but obstructions can impair the signals. We also don't have a lot of huge trees, a lot of growth along the corridor, and so whereas some cities find they need to put these DSRCs way out on the mast arm near the center of the roadway, if you will, we have not had to do that. That's simplified our installation, allowed us to install without closing lanes, for instance. And so these pictures show you a couple of those installations and how we've done that. Some lessons from this, we've learned that the hardware installation is fairly straightforward. It doesn't take long to put one of these up. They're powered over Ethernet, so you run an Ethernet cable down the pole and into the cabinet. We've generally selected the corner of the intersection that has the cabinet on it so that that run to the cabinet is shorter. That's not always the case, but that's generally, we've been able to make that work. RSUs have sort of it's well known that they sort of have a nominal range of 300 meters. That's actually sort of a minimum range. We have generally found that we get much more than 300 meters of range out of these RSUs, sometimes 2 or 3 times that. We have one instance where a message sent, a map message sent from one of these RSUs was picked up by an OBU in one of our fleet vehicles 4 miles away. So that's an extreme case. There was some elevation change. But nonetheless, we get more than 300 meters out of these, quite a bit more than 300 meters. And our vehicles driving down the road often see 2 or 3 intersections in a row at the same time. We created maps for all these intersections. There's really no document out there that tells you how to create a map. There's a spec for the maps. It meets the J2735 standards. We're broadcasting SPaT and MAP according to the 2016 version of J2735, but it doesn't tell you how to create the map. It doesn't tell you how far apart to put the points and some of those kinds of things. And we spent a lot of time in our early map making trying to figure some of those things out and reverse engineering a little bit some other map documents that we had access to and thinking through that. It was not a trivial exercise. It was harder than we thought. Once we got it down, it wasn't bad. We used some high-resolution Google mapping that our state mapping division, if you will, has access to. So we were able to pull that mapping in and pick points on that mapping. On a couple of these intersections, we sent standard survey crews out to verify our point selection, and they matched up really, really well. And so we were comfortable with mapping that way. I'll jump ahead a little bit and tell you we're building a second corridor. On the second corridor, the roadway was under some reconstruction, so we couldn't use mapping for that, nor could we use the USDOT mapping tool because it uses Bing Maps, which are existing mapping systems. So on our intersections for this next project, we actually had to use microstation files and pull our coordinates out of there. So that's just a little bit about this system. You may well know that these roadside units need to be registered with the FCC. The agency has a license for DSRC around the state, and then we worked with a gentleman in one of our other state agencies who handles wireless communication, and he registered these on the FCC site. It's a fairly straightforward process. Once you figure out where the website is and what to put in and make sure you have the right information, it needs coordinates of the location and elevation of the devices, a little information about the device itself and its antennas, and so that's how we've licensed the devices. this is what the inside of the signal cabinet looks like. You can see we've got a signal controller there, and the only things we've really added to the signal cabinet are the Ethernet power supply, the processor power supply, and the roadside application processor itself. We're running our software not in the DSRC unit and not in the signal controller, but in a standalone Linux board, which is in that little roadside application processor box in the center of the picture. So it's a little Linux computer, and that's where we run our software. So in the cabinet, we've got the application processor, its power supply. We've got Ethernet power and fiber Ethernet switch in there, and that's where the device plugs in. So there's not much real estate in the cabinet that gets used for this installation. The SPaT challenge really isn't about working with vehicles, but I mentioned that we moved into a transit signal priority kind of an application, and we installed or onboard units, OBUs, into some city buses. Right behind the driver's seat, there is a cabinet, the upper right-hand picture, an electronics cabinet where all of their radio and electronics equipment are housed. They allowed us, in the photo right under that, to put an onboard unit on one of those shelves, and you can see the onboard unit there with the onboard processor in the little white-colored box. This had a few challenges. We're broadcasting BSM data from the bus, but really the BSM data we're broadcasting is just GPS sourced data, so vehicle location, direction, speed, that sort of thing. We're not connected into the vehicle systems to pull any of the traditional BSM data. We had some challenges getting our onboard units and our roadside units to communicate effectively and get these messages back and forth, and it took us some effort to kind of work through those. Antenna placement on the bus was also tricky. The agency wasn't real excited about us penetrating the roof. You'll notice in this bus photograph there's a little shroud that sticks up in the front of the bus. It's a fiberglass shroud. Our antenna is inside of there, underneath that shroud, so we access it from inside the cabin of the bus and put it up in there. And we had some challenges with ground plane on the antennas, and did some testing to make sure we had reception, etc. But that's where we put that. I mentioned that we tried 4 different brands of hardware. At one point, as we were playing around with getting this hardware to talk to each other, it was not interoperable out of the box, and in some cases still isn't. That's been a real challenge for us, interoperability between these various brands, especially as each of these various vendors changes their firmware and upgrades things and all of that. We've had some ongoing challenges with that. At one point, our staff decided that it made a lot of sense to mount a bunch of these together in one place and connect them into our network along with some signal controllers. That's what you see here in this photo, which enabled us, as software developers were working on our software, they could log in from wherever they were, connect to our network, have one of these devices send it to another one of these devices on the wall. This really helped us for a period of time as we played with interoperability and tested communications. Having everything in one place here really facilitated some efficiency in our operation. We found that it wasn't trivial getting the SPaT data out of the controllers. We worked directly with the controller manufacturers to find the data and get it extracted, and then we create a map message on our Linux board. I think that's getting easier. We were doing this before some of these vendors were creating some of the tools that they now have in the controllers. These are modern controllers, but they weren't yet 12.02 version 3s, where I think some of those problems will be solved. But nonetheless, that was a challenge. I mentioned the DSRC hardware and the capacity of the vendors to support the hardware. That's still maturing. There's still changes. We've got some software workarounds that we've found that we've had to build to make certain things happen, because there were some functions that weren't supported by the hardware, and then as the as the DSRC vendors would change their firmware, that would break some of our workarounds, so we've had to deal with some of that. People often ask about costs, and I list the range of costs for these OBUs and RSUs here on this slide, but I'll tell you that's just the hardware cost, and those are fairly fixed numbers, and they're not terribly, it's not terribly expensive equipment. The real hidden cost, if you will, is really variable, and as we've looked at other sites that have deployed and tried to get a handle on what the costs are, it depends a lot on what you're doing and how you're doing it. And so I've got a list of some of those variable functions here on the bottom right-hand side of the slide. As a for instance, you noted in my earlier slide pictures that we've deployed these along essentially the side of the road, not out over the lanes. Well, if you can do it that way, the installation takes a few hours, and it's pretty simple. If you're closing lanes and putting them out over the lanes, or maybe having to do that at night, well, that's a whole different story. And it takes more time and more people and more cost, and those are hard things to capture because they're fairly site-specific. Some agencies go out and do spectrum evaluations and look at the spectrum in the intersection area, what kind of competition there is. We did not do any of that. We hung these, we put them up, we drove up and down the corridor in a staff truck with an OBU on board to see if we could receive the message, and then if we needed to get up and tweak the device a little bit, we would do that. And there are a variety of other issues here. If you're not doing an application, that's different than if you are. And so those things make a difference. We have not yet implemented security certificates, SCMS. I think it was Joanna that indicated that, well, maybe it was Liz that indicated that up until very recently, a security certificate management system was really not available to us. There are now some commercial vendors starting to pop up who have those, but we have not yet embarked on that. We also haven't done anything with GPS correction, the RTCMs. We've talked about it. We've thought about it. We don't think our application needs it. We think someday there are applications that will need it. We just haven't worked on that yet. So that's another thing that I think we all need to figure out at some point. I mentioned that we're now working on a second corridor. It's a bus rapid transit project that's underway in Provo and Orem, which are cities about 30 miles south of Salt Lake. 47 intersections with 25 buses. There's a photo of one of the articulated BRT buses there. The bus will be in a dedicated lane more than a majority of its run, but not always. They're going to run really close headways, and so we're actively installing hardware on that corridor and in those buses. The bus system, the BRT system, will open for business and start service in mid-August, and we hope to have our system up and mostly running, maybe not perfectly running, but mostly running by that same date. We're also looking at several corridors in the Salt Lake Valley where we would give priority or maybe preemption to snowplows when they're actively plowing, when the plow's down and the spreader's on. And the goal here would be to get them through these intersections, get the roads cleared faster. We've done some analysis of some cost benefit of that, and we think it's justifiable. We're in the process of refining our corridor selection and looking at plow routes, and hope to have some of those up and running, at least a few of those corridors up and running this winter. So those are some of our next steps. Just a few lessons learned, and some of these will mimic the ones that Liz had. As you're getting started, take advantage of others. I mean, these webinars are great, and the resources that the Operations Center has are really helpful. Talk to other states and other agencies. Meet with consultants and vendors that have experience doing this and learn from them. As you prepare a corridor, the first step is really good backhaul and modern signal equipment. If you haven't done that yet, you're going to need to do that for whatever kind of connected vehicle application you might do. So put that on your radar screen, and if you're not quite ready to jump into connected vehicle, this is a good place to start to get ready. And then as you start to think about deploying, look at DSRC compatibility with your controller. Talk to your controller vendors. I believe it's it's a good idea to start small. Everybody can do this. Everybody can start with a few intersections or 15 or 20 intersections. Start small, get your hands dirty, learn how to do this, but keep the future in mind. So as you make decisions, think about scalability. Take one step at a time. If you jump too far in, it can be a little overwhelming. But jump in small and then kind of move from there. That's what I had to present. I think this slide is actually after our Q&A, isn't it, Nilo?
Yeah, could be.
So maybe we ought to jump into Q&A, Nilo, and get everybody responding to some of the questions that have come in and some of the ones that came in earlier.
Sure. So that was a great presentation from our panels today. I see that we have quite a few questions already posed here. So let me start with the first one. And I think this was asked when Joanna was presenting. So the question is, are the Consigna and Siemens RSUs interchangeable or interoperable?
To be determined. I believe that they will be. Right now, the Consigna units are integrated and operating. The Siemens units are being configured right now. Just last week, we had some onboard units installed on city fleet vehicles, and so once the Siemens units are up and running, it's our intention to have those vehicles be able to communicate with the intersections, whether it's a Siemens, Coda, or Consigna unit. Ideally, they will be interchangeable, and we'll work with Siemens and Consigna if needed to make sure that they're interoperable.
Thanks. Anybody has anything else to add to that?
So this is Blaine. I will add that the three pilot sites, New York, Wyoming, and Tampa, recently got together as part of their projects and checked interoperability between the devices they're using at those three sites. And I think there are maybe 6 or 7 different vendors involved. And they had the vendors present, and they were all kind of in the same room, if you will, which is a little different than many of us. But they were able to get all of their devices operate together, be interoperable in that setting. I'm not aware of other instances when that's happened. We had some SPaT Challenge folks here in Salt Lake in the spring, and after a day and a half of work, we got 3 of the 4 vendors we had available to be able to broadcast with each other. So I think there's a lot of progress being made in interoperability, but I don't think it happens out of the box.
Thanks, Blaine. So the next question is, which traffic-aware controllers are being used? I think that is again a question to Joanna.
Yes, and so that one kind of goes with the second question, or the third question there, as far as the do the controllers comply with NTCIP version 3. So our traffic-aware controllers are 980s, ATC, and I believe the NTCIP version is 2. So right now we are working with traffic-aware for the time to change coding there. In our downtown area, our intersections are very small. They're basic phasing and they're fixed time, so the time to change is not elaborate. So for our shuttle project right now, we were able to work around it, but going forward in the future, yeah, we will work with traffic-aware for the time to change and the version 3 requirements.
Thanks. So Blaine and Liz, do you have any comments on that? Like, what is your compliance with which version of NTCIP?
This is Blaine. I don't know for a fact, but I think ours are probably version 2 compliant, 1202 version 2. I don't know that for a fact, but I think that's the case.
In the Northern Virginia testbed, the intersection controllers comply with the NTCP, but the custom firmware installed on the controllers right now broadcast SNMP data to avoid, is for safety measures, to avoid requests of data from external devices. So that's a requirement that VDOT put in place. So we are only allowed to receive data on the RSC side.
Okay, thanks. So the other question that we have here is, what is the fail-safe scenario for the shuttle if the DSRC fails and the shuttle has no information on the signal phase?
Right now, if the DSRC, if one of them is not functioning, they are able to, there is an operator on board the shuttle. They're on board at all times, and they're there to monitor and make sure that the shuttle is operating as intended, and they're there to take control if needed. And so there has been an instance where DSRC has failed, and the operator knows that I believe the vehicle just slows and stops if it doesn't receive the feed, and so the operator is able to take control, and he has taken control and navigated through that particular intersection and then continued and put it back into the automated mode and continued onto the route. So that is a scenario we don't want to have happen routinely. Right now, our driverless shuttle project is more of an experience, more of a demonstration to see how it's received. And once the vehicle does go into operations and provides a transit service, we're not going to want any downtimes, because right now there is the option to take either manual control or not operate the vehicle. And so that's why we are looking at redundancy options for the DSRC.
Thanks, Joanna. So I've asked a few of the questions in the chat box, but we also received a few questions from the registration form from you when you were registering. So I put it in here in slides. So the first and second question is regarding the number of deployed intersections and also number of planned intersections, and also the map tool that each agency uses. And I think all of those are captured in your presentation. So I'm going to ask the third question, but feel free to add details if you like to about the first and second question as well. So the question is here is, if a situation comes up where there is work in the intersection, for example, a flagger is directing traffic and altering the lanes of travel, what would you do? Would you turn off the SPaT map broadcast, alter the map message to accommodate the change in lanes through the intersection, or something else?
And that is a very real scenario, especially now with the roadway projects that are underway, in the Las Vegas Valley. That's a scenario that could happen. And, lane closures could happen at specific times of day. For example, a lot of our work, unless it's by a residential area, is at night. So from 9 p.m. to, let's say, 5 a.m., there could be lane closures. As we're looking at a management software to manage our DSRC, that is part of the scope that we are developing for that management software, in that we can have customized maps for these types of scenarios. If we know that there is going to be a lane shift or a lane closure, to be able to have the ability to update the map for those instances. But today, how we stand is that the map broadcast does not account for that. Today, it's broadcasting based on the current lane configuration. So that will be a future enhancement for our system going forward. And today there's not a lot of connected cars or driverless cars on the road, so the driver can take control and navigate through the intersection. But as more driverless vehicles are on the road, that's going to become more important for sure.
Thanks. Anything else to add to that?
So this is Blaine. I think Joanna hit it right on the head. In the short term, depends on the application you're running. that wouldn't necessarily impact us with transit signal priority. In the long term, we're going to need to deal with work zones, modify our maps. We're going to have vehicles who are going to depend on that from a safety and an operational standpoint, and that's something we're going to have to figure out. We've got a little time, but that's an important issue we've got to deal with.
Thanks, Blaine. So let me see what was the next question. So next question that we had from the registrants was, how are sites obtaining information from controllers? So what devices from what vendors and what kind of controls? And I think you all talked about that. Is there anything you would like to add to that? No, okay. So the other question was, where are messages generated or signed? Is it from the central office or in field?
So in our case, the messages are generated on our Linux board in the cabinet or on the bus. But the signed piece of this question refers to, I think, security certificates, and we haven't done that yet. And so they're not signed at all so far.
Joanna, Liz, anything to add to that?
Yeah, so we're talking for different messages. For example, for SPaT, each of our RSCs installed on the intersection receive the information dynamically from the controllers, and that data is encoded in real time into a DSRC message. So that message is generated at the RSC and be transmitted over DSRC. And we forward that information also to our backend servers to be retransmitted to any other channels like internet or as a backup as well for database purposes. On the map, we have the same capability. We can generate live map data at the RSC if modification changes, for example, lanes or pedestrian lanes have been open or closed or blocked, but that requires currently a manual step from the server to be pushing a new map configuration to the RSCs.
Okay, thank you. So let me read a question from the chat bot this time. So the question is, how long did it take for you to go through the DSRC licensing process?
The process itself is not a long time to prepare the application. For the City of Las Vegas, we coordinated with our vendor, whether it's Comsignia or Siemens. Part of the application includes information about the radio. It includes, so we receive that information from the vendors, and then it includes information about the location, so the elevation and GPS coordinates of the location. And so if you have ease of access to that information, it's pretty easy. So once you get all the information gathered, you can have the application filled out in a day or two. Really quicker than that. It's filled out pretty easily, but do account for, I believe it was 4 to 6 weeks for it to be processed by the FCC. There is a, they have a backlog of applications to review, so there is a certain time that they allocate for approval of the licenses. So the application itself is not time consuming, but there is a processing time.
So I'll just clarify that there are 2 steps to the process. The agency first has to have a license to operate in this band, and so and your agency may already have that. In our case, someone in our agency had already made that application, and we had the license, and it's a statewide license for operating in this band in the state of Utah. And then we did, as Joanna described, went through the process of just gathering the data and filling out the forms. Again, we had a person in another agency who deals with radio licensing and radio operations, and he did this for us. I don't remember the turnaround time being 4 to 6 weeks, but I wasn't maybe close enough to the process to know when that data was given to him and when it came back. So it certainly could be. But on the user, so somebody just told me it was 4 weeks. But on the user end, providing that data once you're used to what that data is fairly straightforward. And Joanna described what that data was.
Thanks, Blaine. So let me go through the next question. So this question is for Liz. Was the construction contractor responsible for the cost of developing the ATSD4 custom firmware?
I'm not sure who they're referring to by the construction contractor, but the funds provided by us and VDOT were used to pay for the firmware.
Okay. So we have another question here about the GPS location. So the question is how accurate GPS locations in basic safety messages are in an urban environment.
So that's pretty variable depending on where your environment is. I mean, GPS accuracy, first of all, is based on how many satellites are visible in the sky. And in the more urbanized your environment gets with taller buildings and things, the fewer number of satellites you might have. And then in real urban settings, you know, New York and Chicago and those kinds of places, you get urban canyons. And that diminishes the capability of getting good GPS accuracy. And someone from the New York City pilot could probably talk in detail about that. They've tackled that problem and have some solutions. But we found in general that the GPS accuracy was good enough for our application, and that's the other piece. What kind of accuracy do you need? Is it good enough just to know which lane a vehicle is in, or do you need to know sort of where in the crosswalk a pedestrian is? And so it depends on your application, and you have to evaluate that. If you need better accuracy than you can get, and the best way to find out what you can get is to get a device and put it out there and start seeing it. But if you need better accuracy than that, there are tools that you can use to augment the accuracy, correction messages you can send. I believe the folks in Caltrans have implemented that in their corridor in Palo Alto, and we've got some webinar information in a previous webinar that talks a little bit about those position correction messages.
Thank you. Anybody care to add to that?
Yeah, I was just going to add too that that's one of the reasons why we have installed an RTK base station up in our VCC test bed, because we do have taller buildings up there, of course, and we are yet to validate that system, but that was one issue that we saw with GPS accuracy for the applications that did need the higher accuracy.
Thank you. And like something that Blaine talked about was the accuracy of the map data. So that's also another question, like in your specific cases and applications that you have, what is the accuracy of your map data?
So the map data we follow the SPaT map challenge requirements. So it is to the centimeter level, plus minus 20 centimeters, in terms of the points taken per lane and moving state. Also, that said, the only thing to compare with or against it is using a differential GPS to verify these coordinates, which we have been doing that in-house at BTTI.
Thanks. So if nobody wants to add to that, I guess I'll go ahead and ask the other question. So this question may be already answered. So somebody's asking Blaine, like what or which RSUs were tested by Utah.
So we started out with Arata and Savari, and then we picked up some Codas, and then Lear bought Arata, and we picked up some Lear units, which were, even though one company bought the other, the Lear units were quite a bit different. So Arata, Savari, Coda, and Lear are the four that we used, both OBUs and RSUs.
Okay, thank you. So the other question I see here is, how has the PoE cable been installed in the polar base? Is it in a separate conduit? Also there's comment that internal question came up regarding how to install PoE in the existing pole and meet an EC code.
So Joanna and Liz aren't jumping in. I will. Ours are inside the pole, go down through the pole and then through a conduit to the signal cabinet. I am not an expert in NEC code. I recently had a conversation with someone who felt that there was a problem with mixing these cables inside the pole. I'm not aware of exactly what that code issue is, but we put ours in the pole. I know there have been discussions about putting in a separate conduit down the pole, and that's certainly feasible. That makes it a little trickier to get it into the cabinet because you've got to get it into the ground somehow, and you can strap a conduit to the pole. We put ours inside the pole.
Yeah, I believe we did similar. I wasn't involved with the direct installations, but I do believe that it was installed just directly inside the pole as well, from the cabinet to the roadside unit on the traffic signal shaft.
Okay. Let's see. So the other question is, it seems that Coda MK5 has decent computing power. Has anybody developed any applications running on MK5?
Yes, BTTI, we developed our applications for the OBE, which consists of decoding DSMs, SPaT, map messages, and use this decoded information to present to the driver, or also to send it to our own data acquisition system. Also, we have been using, along with the cell phone application, so we forward these packets received over DSRC over Wi-Fi to the phone, where the application can use them also as to do specific actions or to show specific messages. On the RSC side, we also develop custom applications for the SPaT and map forwarding and generation of messages, and also to forward our BSMs in a custom message to our backend servers. So all the data being received by an RSC is forwarded to BTTI to get stored in a database, and for that reason we need to make or develop an application to run on the RSC.
So I mentioned that we run our software applications on a single board Linux computer that sits in the cabinet in the bus. But that being said, I think most of the DSRC devices today have the capacity to run applications on board. That wasn't always the case, but I believe it is now. And I think we're seeing three scenarios. You've got the scenario we've done where we run our application on a Linux board. You've got the second scenario where some signal controller vendors are building applications that run on the controller or in a second board that sticks into the controller. And third, on the DSRC units. I think the DSRC vendors are building applications that run on board their devices, and there are probably third parties doing the same thing. So I can't give you specifics of what those applications might be, but I think all of the vendors are working on applications that run on board.
Thanks, Blaine. So we had a few questions both from the registration form and here about security again. So I know you talked a little bit about that. So somebody is asking if network firewall installation would be an alternative to SCMS, or just if you would know of any alternative approaches that would work for the security of the network.
So I'm not a security expert, but my answer to that question is no. The network firewalls and all those kinds of things are an important, crucial part of all of our network communication. But the value of the SCMS is certifying that the message is a valid message. So when the BSM is sent from the vehicle, it's not necessarily going to go through the network. It's going to go from the vehicle to the roadside unit. And when the roadside unit receives that message, it needs to know that it's a valid message, that hasn't been tampered with, and that it hasn't been altered. And the security credential system is what does that. It's a little bit like when you go online to buy something from an online retailer like Amazon, and you use your credit card, down in the corner is a little symbol that says that your transactions are being secured, and that's a security credential management system. And so the vehicle, or the OBU on the vehicle, or the RSU in a cabinet or wherever else it's deployed, would have on board a bunch of numbered certificates, and those are verified back against a master list. So when one is sent from one end to the other, or the receiving end can verify that number against a master list someplace. It's not quite that simple. It's much more complicated than that, but I don't think that replaces a firewall, although the firewall is still an important part of network security.
Thanks, Blaine. We are approaching the end time of this webinar. But we have some questions left, and I know we have the August webinar too, so I'm planning to save some of these questions for that one. But let me ask one last question. So somebody asked, when the deployment continues, do you foresee using internal resources to maintain the equipment or outsourcing the maintenance?
Our plan is to use internal resources, but we haven't thought about it real hard yet.
Same for City of Las Vegas right now, internal resources, internal traffic signal team is maintaining the system.
Okay. So I guess I have time for one more question. So about the vehicles that are used, so the question is, what vehicles are currently accessing the DSRC technology or agency has deployed? Are the vehicles government fleet, commercial fleet, first responders, or privately owned? And also, are there any OEMs that you are currently working with?
Well, in Las Vegas, there are, the driverless shuttle project is underway. Aptiv is currently using deployed DSRC on Las Vegas Boulevard, and we did outfit several of our city fleet vehicles, and right now for the city fleet vehicles is more for monitoring and to see what the messages are, and from there we will grow the program.
What about Virginia or Utah?
As I said in my presentation, we have a fleet of 50 privately owned vehicles right now, and then we have some other users available to use our VCC mobile application through invitation only right now.
So we have transit buses outfitted with OBUs on our Redwood Road corridor, on our BRT corridor, and then we plan to outfit some snowplows that are fleet, DOT-owned snowplows.
Mm-hmm. Okay, yeah. All right. So I guess that would be all the time for the questions. Let's just quickly mention the upcoming August 14th webinar. We will be, like as Blaine mentioned, we will be talking about Connected Fleet Challenge, everything beyond the SPaT challenge, and also I think we are saving some of these questions that you had, like there were a few more that you previously sent to us, and we plan to ask those as well from the panel here. I just want to again thanks everyone for attending today's webinar. I want to also thank the panelists that we had here. They shared some great information with us. You can access the webinar recording, the presentation slide through the follow-up email from NOCO and also from NOCO website. So that is all for today's webinar. I want to thank you again and wish you a great rest of your day. Thank you.